Good afternoon, everyone, and welcome to this webinar. My name is Alexis. I'm from the Akenza team. I'm very happy to have you all join us into this exploration into the world of IoT and digitalization. Today, we have a great case. We're showcasing digital retrofitting case, IoT-based. We're transforming a public pool into a smart, connected full solution. And I have with me today experts from gammaRenax, headbits, and comtac, and that will share their insights about this case and about this digital retrofitting process. So let me share my screen and introduce the speakers of today's webinar. First, we have Patrick Fischer, IoT project manager at gammaRenax. gammaRenax is the initiator of this project, and Patrick will tell us more about the initial situation and their vision for this case. Then we have Stefan Zimmermann, CEO of comtac. Stefan will dive a little bit more into the hardware used in this project and some of the challenges related to the connectivity technology used. Finally, we have Jonas Wittlin, CTO at headbits. Jonas will describe a little bit how they developed a user-friendly web app that answers all the requirements from the projects and that makes sense of the collected IoT data. So let's dive in. The IoT solution creation process comes with a few challenges. First, you need to interconnect different types of components, right? You have a physical layer with the sensors, the actuators. You have a connectivity and device management layer. And at the top, you have the application layer. And all these different components require standardized interfaces and protocols to be able to form a holistic solution. And not only you need to answer to the requirements of the proof of concept of the first version of your product or service if you want, but you need to make sure that this architecture is scalable and flexible enough to adapt for changes in the future. So it needs to be resilient to change. So for that, you need a strong IoT stack, an IoT stack that is able to connect all these heterogeneous components together and support the application creation process. At Akenza, that's what we provide. We have an IoT platform that takes over the whole application enablement layer. So for the ones who don't know us, I don't want to dig too deep into the details, but these are the different stages that we cover with Akenza. At the data input side, we have the different devices, and we have a device library that is able to decode the data coming from hundreds of devices. If you have your own device, obviously, you can also connect it with a custom payload decoder. These devices communicate to Akenza via different connectivity technologies, such as HTTP, MQTT, cellular IoT. We have integrations for that as well, or LoRaWAN, which is the case in the project of today. For LoRaWAN, we also have integration with different network providers. And if you want to know more about LoRaWAN, you'll know much more about it at the end of this presentation, thanks to Stefan Zimmermann. When the data is available on Akenza, we can store it in the cloud, but we can also apply business logic based on the data that is collected and trigger action based on the data coming from those sensors, machines, you name it. The data can then be forwarded to the end application, and that can take multiple forms. So we have output connectors for environment on Microsoft Azure, Amazon Kinesis, Google PubSub, or some people might want to use the data in business intelligence tools such as Power BI or Tableau, or simply pull the data via REST API and use it in your own application layer that you develop for your particular case. And you will learn more about this part with Jonas at the end of this presentation. But let's dive into this case, into this digital retrofitting case, with Patrick, who will tell us more about the vision that gammaRenax had when initiating this project. And I'm happy to hand over now to Patrick.
Perfect. Thank you. So you should see my screen. So hello, everybody. As already mentioned, my name is Patrick Fischer. I'm the project manager at gammaRenax and responsible for the IoT in our company. Our vision is crystal clear. We aim to shape the future by connecting system, people, and processes. This enables us to develop innovative IoT solutions and use data meaningfully to optimize how people work and live. Our mission is to create value through innovative IoT solutions and the meaningful use of data. This value is generated by optimizing work and life processes. We firmly believe that the synergy between system, human, and processes is the key to success. It allows us to overcome obstacles, solve problems, and create opportunities. By integrating system, empowering, and human capabilities and streamlining processes, we develop innovative solutions that provide real value. This is what drives us and contributes us to improving work processes and the quality of life. We are convinced that this collaboration of system, human, and processes is the key to success. But in order to identify the customer needs, the following requirements management process was used, which includes 6 key phases. First, defining and gathering requirements. The aim here is to clearly understand the expectation of stakeholders to precisely document these requirements. Second, the analysis and structuring of these requirements. After gathering the requirements, we break them down into understandable parts and organize them logically. Third, the verification of the requirements. We ensure the requirements are complete, consistent, and in line with the project goals. Next comes the application of the requirements to the system solution. Here we implement the requirements in the project development and the testing process. The 5th phase is checking the results. Regular checks ensure that the project meets requirements and any deviations are corrected. Finally, we have the change management. Changes may be required during the project and must be evaluated, approved, and integrated into the project goals. This cycle is a repeating process, as changes in one phase may be require us to revisit previous steps to ensure the project stays on track. Now that we have an overview of the comprehensive requirements management process, let's look at a specific use case in which this process was successfully applied. We have applied this into a specific challenge in practice. A client from the spa and wellness sector who already used our cleaning services was faced with a problem in the area of lifeguard shortages. The lifeguards were not only responsible for security and emergency assistance, they had also technical responsibilities. The main bottleneck was that in the absence of lifeguards, expertise was lost to ensure the operation of the technical equipment, as there was no one available who was familiar with that. To overcome these challenges, we used the requirements management process, as I mentioned. We looked at all the tasks of the lifeguard and realized that certain processes, such as recording the continual manual measurements of the water quality in the pool, were extremely tedious and time-consuming, as they were still carried out by hand with pen and paper. This task has to be carried out 2 or 3 times a day. In addition, there was also no solution for easily monitoring the water quality, although there were already water treatment systems in the swimming pool that measured the water quality using sensor. But this was done in the analog way. The lifeguard had to go down the stairs to the basement to read the values on the system. So you see, this was a very outdated workflow. But to shed more light on the difficulties, let's take a look at a specific problem we identified. Firstly, the reporting delays. Manual generating of reports leads to significant delays, which affects response time to pool issues. Second, time-consuming manual reporting. The lifeguard was spending considerable time manually generating reports, resulting in inefficient use of their resources. Thirdly, the entire system was heavily dependent on individual employees. The loss of a lifeguard meant not only the loss of time-critical tasks, but also of expertise that is crucial for smooth operations. The lack of real-time monitoring affected the ability to respond quickly to pool issues. Potential hazards could not be recognized and recertified immediately. And finally, the lack of efficiency and accuracy. Manually collecting readings and transferring them to Excel was not only the time-consuming, but also prone to error, leading to inefficiency and compromising to the accuracy of the data collected. This problem illustrates why an innovative pool management solution was desperately needed. The initiation of this project was a reaction to the weakness we identified of the existing manual pool monitoring system and the tedious manual processes. We recognized the need to modernize processes, increase efficiency, and improve the overall quality of the pool management. The aim was to reduce reliance on the manual labor, improve data quality, and enable real-time monitoring, allowing pool attendants and lifeguards to be more efficient, accurate, and proactive. And by following all these steps, we realized with an IoT-based solution, we could add significant value to the lifeguard and make processes much simpler and more efficient. By implementing an IoT-based solution, we were not only able to simplify the process by entering and documenting the values directly via mobile phone, using the example as the previous described workflow for manual measurements of water quality at the pool. We also enabled to monitor the water quality quickly and easily from any location in real time. This not only saved the lifeguard up to 20 minutes per day, but also gave them an efficient way to keep an eye on the pool. Our clear vision of shaping the future by networking system, people, and process is reflected in our three-pronged focus: system, people, and process. By automating the collection of pool parameters, we have improved the data quality, accuracy in the system area. Real-time monitoring enables immediate problem detection and automatic notifications, realizing our vision of the innovative IoT solution and meaningfully use of the data to optimize work and life processes. On a human level, we have to use automation to reduce workload, create space for strategic tasks, and minimize the human error, helping to create added value in line with our mission. In the process area, we have created more efficient workflows through automation, which save time and resources. Real-time monitoring allows us to react quickly to change and problems, which ultimately leads to optimized pool management. These successes reinforce our belief that the synergy of system, people, and process is the key to success, which drive both our vision and mission. But our aim is to utilize this innovative solution not only in the area of pool monitoring, but to see this as the first module of our more comprehensive solution. We plan to extend this technology in the area of maybe predictive maintenance or well-being. However, in order to understand the precise needs of the customers, we have launched a research project in collaboration with the Zurich University of Applied Science. This project aims to record the exact requirements of our customers and develop specific IoT-based solution. We underscore the importance of not only generating data through IoT, but also creating real added value for the people. Our aim is to ensure that the users of the solution not only benefit from the data generated, but this represents the concrete and tangible benefit for them. Now that I've talked so much about the requirements, I'm pleased to give you an insight into the hardware implementation of our solution. My colleague from Comtac will be representing the hardware of our innovative solution. Will you tell you more about this?
Thank you very much, Patrick, for your intro, and I will take it over here, and we will dive deep into the hardware, and hopefully you don't have to be afraid. I have more text-based foils, but I think it's important you have the message of that you can read after the webinar and later on. To give you an overview about where we are now in these processes, we have on one hand side, we have, as Patrick already mentioned, existing units mounted in the field. And we take care that this data comes to the cloud, that we can work with the data on a digital way. And there is a lot of devices already mounted in the field, which have, for example, RS-485 interface, which we can easily adapt with a device from us and then bring the data to the cloud. In this, I will tell you a bit more about technologies, what's possible, and why we choose this LoRaWAN technology in that field. What are the challenges? I think a big challenge is how we can bring data to the cloud. It's always, we have a lot of discussion why you don't connect to, for example, existing infrastructure already at customer site. And the big challenge is to get access over the IT and network-based structures. It's always a big challenge to get the ports opened and all this stuff. And therefore, we have this LPWAN, which I just say a bit more about then later on, technologies which are radio-based and are separate from the infrastructure of the customer, makes it quite easy to install it beside the customer networks, and we don't need permission to get on this network by the customer. That's really a big advantage for a lot of IoT solutions. What stands LP1 for? We hear it day by day if we work in the IoT field. It means low power wide area network. And there are different technologies addressing in that field. One is this LoRaWAN, which I just tell you a bit more, which is very optimized and low power. And even we have this network in the Swisscom field. So Swisscom runs a public network in Switzerland for that. And even in other countries are as well LoRaWAN technologies. On the other hand, we have narrowband IoT and Cat-M technologies. Maybe you heard from that too. These are then in the real, let's say, mobile network technologies which work there, and the SIM card is needed and abonnement is needed. In LoRaWAN, we don't need any SIM card. For sure, if you run it on a Swisscom network, you need an abonnement that you can get the data on it. But you don't need a SIM card. It's more simple on that. What are the big advantages for LoRaWAN and what are the disadvantages? Just in short, one is you can have your own network because it's in the license-free band, so everybody can run their own LoRaWAN network. It's a big pro. And the big pro, even for Swisscom, I just speak to them, is it's very easy to extend the network because you can simply install an additional gateway at very low cost. On the other hand, on a mobile network, it's very expensive to get extra base stations installed in the field. The disadvantages, on the other hand, are the data rate is very, very limited. But for a lot of IoT cases, it's absolutely sufficient. Because you need to think what you like to do with the data. Do you need every millisecond data, or is just fine if you have, for example, every 10 minutes or even once a day or even less the data transmitted to the cloud? And here comes the LoRa that you have an idea. So we are able with LoRaWAN to transmit 50 bytes every 10 minutes. That's really less. But if you are very good organized with that, you can do a lot with that. And here comes the challenge too, to get the solution working, because we are not able to transmit overhead with the data. So we really transmit, let's say, the real data, not passed with no overhead. So on the other hand, you need on the cloud, you need a parser that is able to interpret the data we are sending from the device. And that's a big challenge to get it worked, because here we send in that application, we like to have 5 values: the disinfection, the pH value, temperature, flow, and the instrument display. That's the value 2, which is of interest. And we configure our device that will read out this from these existing devices in the wall we have here and send it over LoRa. And then the data looks like here, which is just a bit stream. And for the cloud, then cloud must know which byte and which position is what. And for that, we call it a parser is needed. So you need for the configuration of your device an exact parser on the cloud so that the cloud can handle the data and understand the data. And that's a challenge to make it understandable at the first hand. But akenza did that very well. So they interpret the data, and we have this data stream. I don't like to go into deep details, but this means these are the path value on the right hand, that you get these values here. And if that does not match the parser, then you get the wrong data out of it. And that's a lot of challenge in the LP1 field, that you have it working at the end with the right parser and everything is set it up correctly. Now we have the parser and everything ready, and we just can add additional devices easily because the configuration exists, and we can just get the parser in the cloud and connect it to the device, and it works out of the box very well. On the other hand, you need to be always take care about radio. Here's a bit more generic approach, but I think it's very important for the IoT too, because as you saw just before, means the equipment is located in the basement. And for all radio, if it's mobile or even this LPWAN or LoRa technology, it's a challenge always to get radio access to the basement. And for there, it's just that you have that in mind. It's very important to place your device at a good stage or the good place in the house or where you install it, that you get a good radio connection. And you see, we have the absolute worst case for radio is forest, because we have a lot of water in the forest, and this is the maximum damping you can get out of anything. And if you go through concrete walls, you have a big damping too, and even you have reflections and a lot of interference you have in the field, which gets the signal worst. It's the same for you. If you take your mobile, you see the 5G symbol on it. It doesn't mean you have 5G speed at the end, because you have a lot of interference at that. And that's very important to place your device carefully, and then you get less problem about radio coverage. That's the message for this. What means it with LoRaWAN? LoRaWAN has a special mechanism to it. So the absolute world record in distance, but we need to be careful about that, is in free space air. So their record is around 800 kilometers of range we can achieve with very less power. A typical range, we always say to customer, you have in city, in urban areas, you get more or less 1K range. And if you go in a building, you need more or less 1 gateway, we say, per building, that you get a good coverage. Otherwise, it gets challenging. Even if you use the mobile network from Swisscom, so it's a gateway outside, then you need to check at the stage you were using it, if you have really connection or not. Because it depends, especially that you have line of sight of the gateway, it's always the best. And LoRa has different spreading factors. It's very deep technically. And as more we spread the signal, as longer is the range, especially for breadth-driven devices. But it's important to have a low spreading factor, because then you have really a short time on air, we call it. The message goes fast through the network. And if you have spreading factor 12 for the best coverage, you need to send longer and you spend more energy on that. In this use case, we are now located auto-driven by mains, so it's not so important about this. So we can use more energy in that field because we're always connected to the mains. What we have done, we take a measurement in the praxis, that you have an imagination of that. So this is the Glatt shopping mall located in Zurich. We have a big parking lot around the main building. And with one gateway, we was able to cover all the building and even the parking area, which is over 300 meters long and approximately 50 meters in distance. And we connected everything. So it means with less effort, you just connect one gateway, you have coverage of the whole building. It's a really good result at the end, that you have a good coverage with less installation effort. That's really good. At the end, just a few words about us. So we are the hardware guys. We had a lot of devices to connect data and bring that to the cloud and sensors. we did a lot of in the IoT field. And now what's done with our data? I'm happy to handle my presentation to the next presenter. It's Jonas, which will tell you a bit more about the visual. So because our solution you don't see typically because it should just work and you don't see, it's not good if you see it because that means no, something doesn't work right. But that's the good thing from Jonas. It's more visual and it's pretty cool to see what is done with the data from us.
Yes, thank you very much, Stefan, for the introduction. So as we continue with today's webinar, I have the pleasure to cut it off and kind of talk about the last part of the pool solution, which is the Argus or headbits Webapp. And I would like you to take you through the process that led to its creation. So I want to start off this, my part with basically this slide here. So throughout the whole project, making sense of the data was really our key vision for Argus. And in order to execute on this, we defined kind of some high level and central requirements. So we knew it had from the beginning, it had to be multi-user and multi-tenant. It should be hardware agnostic. As Stefan mentions, you can plug a lot of hardware and we wanted to support all of it. We knew from the beginning we had multiple data sources, so our own database, but also the data that is in the akenza databases. As Patrick already mentioned, we had extended reporting requirements with cantonal templates we had to support. And also, we knew we had to have an efficient architecture to keep the costs of running the solution under control. And all of that combined had to be a solution which is fit for non-technical users, typically lifeguards, pool attendants, or other staff working at spas or other companies. So again, as mentioned by Patrick in the first part of this webinar, at the start of our collaboration with gammaRenax, they had already established the requirements and also workflows that would be necessary to fulfill their goal. So our role was really to just transform these requirements into intuitive, user-friendly interfaces and screens, but also keeping a close look on the overall information architecture, making the app as easy to navigate as possible. Throughout this initial phase, we delivered a clickable prototype that was showing a real-world example of what we are going to build in the next phases. The next phase of the project was to turn the clickable prototype into a real product. For this process, we really embarked on a journey marked by iterative refinement. By incorporating feedback from gammaRenax and also our future users, we finalized our designs and we aligned on the key features that we deemed to be essential for the initial release of the app. The key features that we wanted to start with were user management. So we knew from the beginning that we wanted our tenants to be to do most of the administration themselves. We wanted to have a pool overview and the manual measurements. Reporting and exports were always key for Argus, so it had to be in the first version as well. Alerting and notifications, and also the document library. The document library can be used by the tenant or gammaRenax themselves, so they both have separate spaces, and it allows them to distribute documents regarding, for example, the management of the pools, standard procedures, or information about the products used or promotions. This feature really, the idea behind this feature is to transform Argus into a central hub for the pool management in the companies that are using it. So continuing our journey through the project, we next focused on defining the architecture that we wanted to have. This step was basically vital in supporting Argus's key features and paving the way for our future plans. It involved establishing an architecture that meets our immediate needs, but also being flexible enough for all our future ideas. So for Argus, we developed a pragmatic, event-driven, and cloud-native architecture that focuses on delivering practical benefits, which I want to discuss in more detail with you now. So first, I want to start with the reduction in operational overhead. This is mostly achieved due to our usage of managed services wherever possible. So it starts with our database, which is the cloud data store. It continues with the access management and login, which is implemented using Firebase authentication. But it also continues in the way we host the actual API, the business logic. The high reliability comes from multiple key aspects. Firstly, we have really high uptime guarantees from the vendors that we are using, but also using the managed backups of all of these services provide, we can revert pretty much to any point in time, should we ever have to, without the additional operational overhead of kind of planning backups and having a backup strategy. But there is also another key aspect of the architecture that is highlighted with this orange arrow you can see on the sketch on the right side. The Argus web app connects to the Cloud Firestore directly and can read and subscribe to the data in there. This not only means that we have real-time values in the app, but also that using basic features of the app do not require a connection to the API server at all. This architecture also contributes to the fact that the Argus application can be, the read-only version of the Argus application can be used offline. The scalability comes from the fact that we use a serverless architecture, employing Google Cloud Run and also a managed database, the Cloud Firestore. This means that we can not only very quickly and without any changes to the configuration scale for example, 50 instances of the API, should we ever have to, but equally important, we can scan the whole thing to absolutely zero. This all happens without a compromise in user experience. The direct read from the data from the Cloud Firestore ensures that the user does not have to wait for the API container to start up before responding to the requests. And even if the user would have to wait for the API container if he wants to do a read action, cold start time of these containers are well below 10 seconds using the modern best practices. And also, the scalability is the major contributor to the cost effectiveness. Basically, we tie the infrastructure costs to the usage and also then success of the application. If there is less data coming in, the whole architecture will cost less to run. Now that we have basically discussed the overall architecture and in the beginning, the process how we derived the features, I want to do a deep dive with you into some central aspects of the application. And to start this off, I want to show you the workflows. Our app, Argus, centers around a flexible workflow system that is tailored to meet a variety of operational demands. It offers seamless synchronization with the Akenza platform, yet you can also operate completely standalone within the Argus app. The manual measurement workflow, which I want to focus on now, is one of the two key workflows for pool management in Argus, and it showcases the flexibility and simplicity of the system. On the left, you can see the workflow selector, which pre-filters the available workflow depending on the device type. In the center image, you can see the form, which consists of standard components, including client-side validation, which is done in addition to the server-side validation for instant feedback, which, as Patrick mentioned in the beginning, has the goal to reduce human errors while entering these measurements. And on the right, there is a custom signature component, which is only used in this manual measurement workflow. If a user completes this workflow, we sync it back to akenza, making sure that we have a central repository for the measurements, no matter if they're done by hand or sent by a sensor. So this workflow architecture allows us to build a variety of workflows, and due to the standard component architecture and library, we can keep the development times low and therefore also cost. It is important to know that with these workflows, the goal is to, as also Patrick mentioned, be able to support a variety of other modules, all within this central way of building these complex business processes. The next key feature I want to show you is basically how we interact with the data. So we basically have two ways to interact with the data using the Argus web app. Firstly, you can use the Argus app directly to look at the automatic and manual measurements in a combined view. You see a small overview of it on the right side with these three phones. You can also compare multiple pools with each other and define custom date ranges to refine the displayed data. This allows our users to answer most of their questions directly in the Argus app in an intuitive and hopefully quick way. By the way, the whole solution also works on desktop. So if you need a bigger screen, Argus got you covered as well. For the extended reporting, such as the reporting to the cantonal authorities that Patrick mentioned, we build a sophisticated export functionality directly into the tool. The report that you can see a preview of on the left side combines the automatic and manual measurements that and brings it into a format the cantonal authorities accept. This report can be generated ad hoc and is also sent on a weekly basis directly to the administrators of the tenant. After a quick review, they can forward it to the respective authorities. This again ties into the goal to reduce workflow, to reduce the workload, and also reduce human errors by filling it out automatically for the users. The last part and the last feature I want to show you is the alerting notification. And I specifically also chose it to explain when we are using features from the akenza platform and when we decide to build our own. Alerting and notification is an important part of Argus. We want to proactively inform our users should we detect any problems so they can work on it and hopefully solve it before the critical thresholds are even needed. This again ties into the goal of reducing the time it needs to fix a certain water measurement, for example, in this context we are in. To create a good user experience, we had to extend the notification needs and decided to build it into the platform Argus itself, instead of using the features that akenza provides. And with this extension, we can now have the same notifications on multiple channels. So we have web push notifications and mobile push notifications. We can send SMS and we can send emails. Also, our users can define custom breaks from notifications. So when they go on vacation or when they, for example, have a break on the duty, they can customize the break either for a day or a week, or get no notifications at all. And also for the future, we could support kind of on-call schedules, so we know exactly who is responsible for which pool, and we can send out the notifications more precisely to the user that needs to act on it. This was my quick overview of the solution we built together with akenza, gammaRenax, and I would now hand it back.
Great, thank you very much, Jonas. I hope that by now you have a better understanding of the different components of this solution and how this project was initiated and led to this digital retrofitting case. I think it's a great case because here we see what happens when one wants to upgrade an existing system that relies a lot on manual steps, and with the limitations we know regarding to inefficiencies. I think it's a great example because it's not about replacing the system, but upgrading it with additional components, with an additional connectivity layers that enables new digital services, new automations, better efficient workflow. And that combines as well some manual entries, some automated ones, into a holistic approach. Thank you very much for joining us today in this webinar. It was a pleasure to showcase this smart pool solution case together with gammaRenax, comtac, and headbits. I wish you a great afternoon and see you next time.